This is Secondary 1 Math, lesson number 11-2.
Okay, going over the warm-up. Number 1, inside your parentheses you've got 4 and 20, so I'm going to first write 20 like that, and then I've got x to the second, and you don't have to do it this way, but if you're not really sure, then do this. Now remember last time I told you that if you've got anything inside the parentheses, you want to get rid of that before you worry about the exponents. So now what I've got is I've got x v on the top and then 5 on the bottom. Now if you square that, you're going to have x squared v squared over 25, and then that would be your answer. Okay, so that's your answer to number 1. Okay, number 2. Inside this first set of parentheses, the n to the 0, that's just going to be a 1. And so you don't have to worry about that. So I've got 12m to the third times negative 5, and then mn to the 7th. So 12 times negative 5 is negative 60. M to the third times m to the first, that's m to the fourth, and then n to the 7th. And so that's your answer for that one. For number 3, there's nothing inside to clean up, so I'm going to have 6 to the 4th, b to the 4th to the 4th, so that's b to the 4th 4 different times, so that's to the 16th, and then c to the 4th. So 6 to the 4th, you can use your calculator for that, so that's 1296, and then b to the 16th, c to the 4th. Okay, and then for number 4, everything inside of this parenthesis is being raised to the 0 power, so that whole thing is equal to 1. Okay, number 5, p to the 0, that's just 1, and so 8 is 2 times 4, and then I like to do it this way when I'm showing people how to do it, because then they can see exactly what I'm doing. So you didn't necessarily have to do this, but I'm going to. And so I'm going to go through and cancel everything that's the same, top to bottom. Whoops, not the m. So what I've got left is I've got 2 and then m to the second, n to the second on the top, 3. Oh, looks like I could have done one more n. So let me do that. Somehow I missed that. And then so 3p to the 5th. And so that's my answer. Okay, now number 6, find the area. This is a rectangle, so it's base times height. So you're going to take your base times the height, and then just multiply it. So 24. Okay, b to the first times b to the third is b to the fourth, and w to the 6th times w to the first is w to the 7th. And so that's going to be in centimeters squared, because area is always units squared, and that's my answer. Okay, the next one's a triangle, and so that area is 1/2 base times height. So I'm going to do 1/2 times the base times the height. So I'm going to do half of 10 is 5, and 5 times 6 is 30. You're not going to do half of 10 and half of 6. You're just going to do it one time. So that takes care of those. Then I'm going to have h to the third times h to the second, so that's h to the 5th. K to the second times k is k to the third, and that's going to be in feet squared. Okay, and then last, the volume is length times width times height. So I'm going to take all 3 dimensions and multiply them. So it's kind of a lot here, so I'll just start with doing these 2 small ones here. So 4 times 3 is 12, m times m squared is m to the third, and then times n. And I'm going to multiply that by this one. So that's times 14, m to the fourth, n to the second, p. So 12 times 14 is 168. M to the third times m to the fourth is m to the 7th. N times n to the second is n to the third. And then p, and that's going to be in yards cubed because it's volume. Okay, so that's the warm-up. So let's go on to the lesson. Okay, today we're going to talk about negative exponents. And you have seen this before, especially with scientific notation, but you've seen it before in 8th grade. But a negative exponent, like when you have, 3 to the negative second, that means something different than 3 to the second power. It also means something different than negative 3 to the second power. Those are not the same things. So let's talk about what a negative exponent is and what it does. A negative exponent, or the power, I like to look at it as kind of a red flag. And that tells us that the base, remember the base is like if you have x to the second, the base is the x. The base is in the wrong place. So if it's in the numerator, it should be in the denominator and vice versa. When you move the negative exponent to the right place, then the red flag goes away. So for example, if we have 5 to the negative second power, that's the same as 5 to the negative second power over 1. So the negative 2 tells us that this 5 to the second power is in the wrong place. So I'm going to switch it. So the 5 to the second is now in the denominator. So 5 to the second is 25. So 5 to the negative second power is equal to 1 over 25. Okay, another example. If we have 4 over m to the negative third. M has a negative third exponent. So that tells me that m is in the wrong place. So m to the third is going to come up to the top. 4 is fine where it is. So m comes up to the top with no negative because we're moving it. So once we move it, there's no negative. And so that's what the answer is for that one. Okay, on the next one, next example, x to the negative 5, that means that that's going to come down. And c to the negative second, that means that's going to come up. So basically they're just switching places. On the last example that's in this set right here, the 5 does not have a negative exponent, so that's going to stay right where it is. The r has a negative exponent, so that's going to move, but that's the only thing. So the 5 is by itself, and then we're going to have 3, and then we're going to have r to the positive fourth because it's moved, and then v. And so that's how you simplify expressions with negative exponents. So that's what we'll be doing in this lesson. Okay, so let's do these examples. So number 1, we're going to simplify. So what I like to do is I like to write this out. So I'm going to write 4 times 3 is 12, and then m to the 8th power. I can just do that, and then n. And then on the bottom, I'm going to have a negative 1 times 3, and I'll show you why I like to do that in a second. Then m to the second, and then n to the negative fourth. Now since n to the negative fourth, since that has a negative exponent, it needs to come up here. So I'm going to put n to the 4th power up on top. So what I've got is I've got my 3's, and that's why I like to pull the negative out, because then I've got 4 divided by negative 1, so it's just negative 4. Now m to the 8th over m to the second, that means that I have 6 extra m's on the top times n to the 5th, and that's my simplified expression. Okay, let's try number 2. Okay, 5b to the negative 4th. Notice that b has the negative exponent, but 5 does not have a negative exponent. So 5 will be staying where it is. b is going to come down to the bottom. 15 is fine where it is, and b is fine where it is. So 5 and 15, since 15 is 3 times 5, the 5's will cancel. I'll be left with 1 on the top. You never have 0 on the top. It's going to be 1 if everything cancels. And then 3 times b to the 5th power. So that's how you would write your answer. FYI, another way to write that exact same expression is 3b to the 5th power to the negative 1, because that would mean that everything needs to be on the bottom in that. But you're not going to write it like that. I'm just telling you in case you see something like that later. Okay, like in the next problem, if I've got x to the 3rd power and it's in parentheses, that means all of it is to the negative 2nd power. So that means all of it's in the wrong place. So I'm going to do 1 over x to the 3rd power, and then it's still to the 2nd power, just not the negative 2nd power. So I use my rules of exponents like we learned last time. 1 over, and then x to the 3rd times x to the 3rd is x to the 6th power. And so then that's my answer. Okay, let's go to the next one. So number 4, I want you to pause the video and then you try number 4. And if you're a fast finisher, you can get started on number 5 as well. Stop the video for about a minute. Okay, and number 4, the negative 1 exponent, since it's outside of the parentheses, it means everything in the parentheses has to switch places. Okay, so everything moves. So 8m to the 7th will come up to the top, and 24m to the 5th will come down to the bottom. And then since it's still going to be to the first power, just not -1, but since to the first power doesn't do anything, it doesn't really matter if we have it there. Then all you need to do is simplify that. So that's 8m to the 7th over 3 times 8m to the 5th, and so my 8's will cancel. I'm left with m to the 2nd power, because I have 2 extra m's on top, over 3. Okay, number 5. You may or may not have started this, but please notice that only D has the 0. So right there, that's the only part that we're not going to worry about. The rest of it has 1 or other exponents. So anything with a negative, you move it to the opposite place. So I like to start with an empty fraction bar, and then I'll just start moving things. So a to the 5th is going to stay. B to the -7th will come down here. And then C is going to stay. A to the -1 was on the bottom, now it's going to be on the top. C to the -5 was on the bottom, now it will be on the top. D to the 2nd will stay on the bottom. Now you just combine everything that you can. So the A to the 5th times A to the 1st is A to the 6th. C times C to the 5th is C to the 6th over B to the 7th, D to the 2nd. And so that's your final answer. Okay, so number 6. This one, there's a couple different ways to approach this problem. There's a couple different ways to approach a lot of problems, but I'm going to show you what I think is the easiest way. And so I like to kind of compare it to if you're going to move out of your room into your brother's room, and you've got like a lot of trash in your room. You don't want to move all the trash. You're going to throw all the trash away, and then you'll move everything else. So I kind of like to compare it to that. So what I like to do is inside the parentheses, I'm going to worry about cleaning that up as much as I can first, and then I'll deal with that. So inside the parentheses, I've got 3 and the 5. The x to the 0, that's just 1, so I'm not going to worry about that. This y to the -2nd, that's going to come down, and the y to the -3rd, that will come up. And then I've got z over z to the 4th. So now if I simplify all that, I'm going to have my 3 and my 5. Okay, the x to the 5th can't cancel with anything. If I've got y to the 3rd and y to the 2nd, I'm going to have an extra y on top. And then z to the 1st over z to the 4th, I'll have z to the 3rd on the bottom. Now I'm going to take that and I'm going to square it, which means everything in there gets squared. 3 gets squared, x to the 5th gets squared, y is squared, 5 is squared, z to the 3rd is squared, and that's your answer. So you have to remember that everything in there, every single little piece is going to get squared. Okay, so the next one is kind of a combination of a couple of things. So the first thing we're going to do again is we're going to make sure that everything in here is as cleaned up as it can be. So I'm going to start with a fraction bar. I have -1 times 4, and then m to the 5th, and then on the bottom I've got 2 times 4. M to the 0 is just 1, so I'm not even going to write anything. And then n to the -2nd, that's going to be on the top as n to the 2nd. So what I've got is I've got -1 times m to the 5th, n to the 2nd, over 2. Now you don't have to write -1, but there does have to be a negative on there. Okay, next thing is we've got a -3 exponent. So the negative part of that tells me everything needs to be in a different place, so everything switches position. So I'm going to just turn it upside down, it's just a reciprocal, and then I'm going to raise that to the 3rd power, which means everything gets the 3rd power. So I'll kind of write over here because I'm out of space. So 2 to the 3rd power is 8. -1 to the 3rd power, that's -1 times -1 times -1. M to the 5th, m to the 5th, m to the 5th, that's m to the 15th. N to the 2nd, n to the 2nd, n to the 2nd is n to the 6th. So you can leave your answer like that, or instead of the -1, you could just put the negative with the 8, and then just take the -1 off. It doesn't really matter, it's the same thing either way. So that's how you would do number 7. Okay, so the next one, number 8, well 8 and 9 I guess, go ahead and try those. And so pause the video for about a minute or 2 minutes at least probably, and see what you can do with that. Remember, just small pieces at a time. Don't try to take on too much. That's a really good way to get yourself in trouble. You need to write everything out and don't skip anything. Okay, number 8. Inside the parentheses, I've got 24 and 32. I know that they're both multiples of 8, so I'm going to have 3 times 8 over 4 times 8. And then b to the negative fourth, that's going to come down. Y to the 0, that's just 1, so I'm not going to worry about it. Z to the 6th. Then on the bottom I've got v, and then y to the negative third is going to come up, and z to the negative fourth is also going to come up. So now I'm going to simplify that. So the 8s are going to cancel, so I'll have 3 over 4. And then I've got v to the 5th on the bottom. That takes care of that. I've got z to the 6th times z to the 4th, so that's z to the 10th. And then y to the 3rd. Okay, so that takes care of everything inside the parentheses. Now I've got all of that to the negative 2nd power. So just like in the last problem, that negative means everything needs to switch places. So I'm going to swap everything. So 4v to the 5th will be on top. 3, y to the 3rd, z to the 10th, I'm just doing those in alphabetical order, will be on the bottom. And now it's to the 2nd power. So that means everything in there now gets a 2nd power. So 4 to the 2nd power, v to the 5th times v to the 5th. 3 to the 2nd power is not 6, it's 9. Y to the 3rd times y to the 3rd. And z to the 10th times z to the 10th. And there's your final answer for number 9. Okay, last one, number 9. This one, since we've got different exponents on the top and the bottom, you have to deal with each piece of this separately. And so because of the separate parentheses, I cannot cancel like the 5 and the 10. I can't do that. So what I'm going to have to do is I'm going to have to deal with the negative signs first. So that means that what's right there is in the wrong place. So I'm going to have to put 10a to the 3rd c on the bottom, and it's to the 2nd power. And then the 5, that part is going to come up to the top, and that's to the 3rd power. Okay, now I can deal with it piece by piece. Again, I can't cancel the 5 and the 10 because they're different parentheses. So on the top, I've got 5 to the 3rd power, which is 125, but I'm going to leave it like that because I'm going to be able to cancel something in just a second. And then a to the 3rd, and then a to the 5th, or sorry, c to the 5th, c to the 5th, c to the 5th, is c to the 15th, over, and then I've got 10 times 10. So what I'm going to do is I'm going to write 10 times 10, and you can maybe see why I'm doing it that way now. A to the 3rd times a to the 3rd, and then c to the 2nd. Okay, so now I can cancel some of the 5s. I've got a to the 3rd over a to the 6th, so I have extra 3 down here on the bottom. And I have extras on the top for the c. So what I'm going to have is I'm going to have 5, and then c to the 13th on the top, over 2 times 2 is 4, and then a to the 3rd is what I've got left over on the bottom, and that is my final answer. So it comes out looking a lot better than it did originally, but that's how you simplify those. So on your homework, you're going to be simplifying a lot of expressions with negative exponents. If you're not sure if you're doing it right, you can check the answer key and see if you're doing it right, but you're not copying down the answer key.